Welcome back to the Math Professors. Topics in this class can be found in your algebra, statistics, linear algebra, the calc sequence, and so on. So if you like the free content and want to help us grow our channel, please consider liking, subscribing, and sharing. So today I want to cover how to find a z-score given a percentile or a cumulative area from the left. So really just kind of working with the z-score table and really how to identify a z-score from an area instead. So the very first question is asking us to find the 90th percentile, or P90. Now there's two ways you can look at this. When you look at your bell-shaped curve, what P90 really says, it says the cumulative area from the left happens to be equal to 90%. So what I've done is I've given you this area as opposed to the previous video where I've given you the z-score. So what I know is that this is equal to 90%. And I'm going to write this in 4 decimal places because when you look at your z-score table, you're kind of trying to find a number that's equal to that or super close to it. So our real goal is the answer to this question, P90, is this z-score. So that's really what we're asking for. What is the z-score that gives me a cumulative area to the left of 90%? Or, sometimes they write this as, what is the z-score that gives me 0.10? So this notation of z, which is equal to 0.10, represents the area to the right of that z-score. So you can see that these things are equivalent. If area to the left of that z-score is 90%, then area to the right of that z-score is going to be 10%. So these two things really mean the same thing, and depending on your book, sometimes they'll ask for the 90th percentile, or sometimes they'll ask for that z-score with a tail of a 0.1. All right, so again, we're trying to find this z-score. So what I need to do is in your z-score table, what you're trying to find in the body of the table, you have your z-scores. I'm trying to find something in the body that is close to 90% as possible. So what I'm really hoping for is to find something that looks like this. Now, when you kind of drop down, so you find a number that's close to 90, and then when you do that, you kind of move left and right and see if you can find that number. And actually, the number that we find that is closest to it is 0.8997. Now, the number to the left of that, just to make sure you guys kind of understand that, this is going to be, so the area to the left of this is 8980, and the number to the left of this is 0.9015. And really what I'm looking for is I was trying to find 90%, and it wasn't in there, but this is the closest number to this. Now I know that it's much farther than this over, so this is the z-score. But when you drop this thing, so when you drop this down, you can see that my target area is going to be this 8980, and when you take this up to that particular z-score, you can see that the z-score is going to be equal to 1.28. All right, so that's what this is equal to. So this is a z-score of 1.28, which is the answer that we're looking for. Now I want to do one more example. So let's find an example. Let's say determine P95. Now P95 is or I can say, sometimes the book will ask you this as well, right? This is if area to the left is 95%, then area to the right is going to be 5%. So really this is just that z-score that gives me that area. So if I look over here, let's do this in color. This is going to be the distribution curve, your bell-shaped curve. I have an area in this case is going to be 95%. So the area to the left is 0.9500. So again, what I'm going to do is I'm going to go to the body of my graph for my z-score table and try to find 95%. It just so happens to be one of those special numbers, and you'll see a star in between that. Let me write this down. So what you get when you look at your z-score table is you're going to drop it down and you're trying to find the area that's closest to 95%, and you're going to run into these two numbers. Now, in the previous case, I can see that 8997 is much closer to 90%. I'll just say this is 15 units too big, and this is 20 units too small. Units being that fourth decimal place. So in this case, what I can see is that this is 5 units too small, this is 5 units too big. So they're actually equal distance from that target area. And in your z-score table, you'll see this little tiny star. It only happens in a couple spots, and that happens when there is no closer value, that they're actually equal distance. And if you track that star all the way down, way back over here, it's going to say 1.645. Now this is going to be way down at the bottom of your table, which really represents that z-score. It'll say z is equal to 1.645. And the reason why that's the case is because This number is 1.64. This number is going to be comes from a z-score of 1.65, and the mean, the arithmetic mean between those two numbers happens to be that 1.645. So this is going to be that target z-score. So that concludes this video, finding a z-score from a percentile or a cumulative area from the left, or even an area from the right when it's given in this form. So if you like the content, please consider liking, subscribing, and sharing.